With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a wheel of mass m and radius a and a moment of inertia ig about the center of mass is set rolling with angular velocity omega up the rough inclined plane of inclination theta. Distance traveled by it up the plane is. So if I draw the inclined plane, let's say this is the inclined plane, and on this inclined plane a wheel is set into rotation. So if you see, this angle is theta, and on this a wheel is set into rotation. So if you see, let's say it goes up by a distance of s0. So the height through which it will goes up will be this, right? You can get this if you see this is s0, right? And if you join this line, it will be a triangle, right? So you can see here this is s0 and this is theta. Then this height through which it goes up, it is s0 sine theta. So if you see here, it is performing pure rolling, right? It is rolling with angular speed this, right? So we know that in case of pure rolling, the point of contact is at rest because the surface is fixed, right? On the fixed surface, it will have the same velocity as that of the surface, and the surface is not having any velocity, so the point of contact P will have net velocity 0. If you see here, the velocity, let's say the velocity is v and angular velocity is omega, you can get the relation between them, right? So v is in upward direction, omega r is in downward direction. So velocity of point P, it is this. So if you see here, this is 0, so you'll get this. Now after traveling h distance, let's say it stops and its velocity becomes 0, and its omega will also become 0 because at any instant v is equals to omega r, since it is performing pure rolling. And in case of pure rolling, the point of contact P remains at rest. Point of contact So if the point of contact remain at rest, then work done by friction will be 0 because the point of contact at which the friction force is acting is not moving. So I will write work done by gravity is equal to change in translational plus change in rotational kinetic energy. Initially they was at rest, so it will be simply the final kinetic plus final potential, and initial the both were 0. So work done by gravity, if you see here, it moved by a distance of s0 sine theta, that is h. So I will write work done by gravity is minus mgh, and it is equals to. Now if I write down the work done by gravity, so it goes up by a height h, so in opposite to the gravitational field, so I will write minus mgh is equals to plus rotational kinetic energy, it is half I omega square. So I about the center it is given that it is Ig. So I will write Ig omega square. So initially the omega is given in the question, it is this, and we can get this V also. V is omega, you can put the value, and if you see the radius here, radius is also given, it is a, you can put the values now. So if you see here, h is s0 sine theta, where s0 is the distance moved along the incline, and half it will be Here the radius is A. Now you can take this omega square by 2 common. So here the minus sign you can cancel out, right? So you can take this omega square common. So if you see, we wanted this S0, right? So if you divide this mg sine theta on that side, I will write S0 is equals to omega square ma square plus ig. In division, I will write mg sine theta. And this will be the answer of this question. The distance through which it will move up the incline is this. You can check the option. B is the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.